Today's video is going to be on midsegments and mid-triangles. Let's go ahead and first start with the midsegment. When you have a triangle, you can draw a line through the middle of the triangle, and this segment right here is called the midsegment. What the midsegment does is it connects the two midpoints together. So it connects the two midpoints of the sides of the triangle. Notice that these two are congruent and those two are congruent, but not all four pieces are congruent. We also know that the midsegment is going to be parallel to the third side. So the midsegment and this third side right there are going to be parallel to each other. And then we know that the midsegment is going to be half the length of that third side. So let's say that this segment is AB and this segment is CD. When we say the midsegment is half, I can say that AB is half of that third side of CD. Now, sometimes we don't want to deal with fractions because if we're taking half of an odd number, we're going to end up with a decimal. You can also think about it in the reverse order. Instead of AB being half of CD, we could say that CD is going to be 2 of those segments ABs. And if you use this one, you don't have to worry about having those decimals. Let's go ahead and look at this. Solve for x, y, and z given that AB is the midsegment. So this vocab word right here, when I see the word midsegment, I'm going to go ahead and mark everything that I know. So I know that it's going to connect two midpoints, so those two segments are the same, which means these two segments are the same. And I also know that these two sides are going to be parallel to each other. We go ahead and start with x. Here are my x's. This is going to use the fact that AB is equal to half of RS. When I look at RS, I see that if I took half of this, I would end up with 1/2 x squared, and I don't want that. So I'm going to use the other one, that the big segment RS is equal to 2 of the ABs. So RS is x squared minus 2x, and then 2 of those AB segments of 3x minus 6. Giving us x squared minus 2x is equal to 6x minus 12. And yes, we are going to have to factor, so I'm going to move that 6x over, giving us x squared minus 8x. Then we move the 12 over, plus 12 is equal to 0. We're looking for two numbers that are going to multiply to the outside and add to the middle. So those two numbers are going to be a -6 and a -2, because -6 times a -2 is a positive 12. A -6 plus a positive 2 is going to be, or sorry, -6 plus a -2 is going to be a -8. So we have two possibilities. X could either equal a positive 6, or x is going to be equal to a positive 2. If we go back and we start plugging these values in, and I plug them in here, 2 squared minus 2 times 2, that ends up being 4 minus 4, which is 0. If it's 0, then the segment's not existing, which means 2 is not going to be our solution. We have one solution for x at equaling 6. Then let's go ahead and look at y. I see y down here. I see 58. We're going to use the fact that we have these parallel lines. And because these lines are parallel, these angles are corresponding angles of parallel lines. So our parallel line property unit is going to come back into play. And corresponding angles are going to be congruent, which means y is going to be equal to 58 degrees. Then we go to z. Well, z is segment BS. And because we were told it was a midsegment, we marked each of our sides as being congruent because B is the midpoint. If B is the midpoint, it divides CS into two equal pieces, which means that Z is going to be equal to 8. All right, so we take these midsegments and we create a mid-triangle. What a mid-triangle looks like is if we have a triangle, we have a mid-segment here, which means these two pieces are congruent and these two pieces are congruent, but then I also draw in this mid-segment. This mid-segment makes those two congruent and these two congruent, and I draw in this mid-segment. That divides, so I'm connecting all three midpoints to create a triangle in the middle. The inner triangle is formed by those three mid-segments. And because they are mid-segments, we don't want to forget about the fact that the opposite sides are parallel. So this line is going to be parallel to this line, not opposite sides, that mid-segment and the third side. And then this segment is parallel to this segment. And last, this mid-segment right here is going to be parallel to this third side. So I've got three sets of parallel lines that we're going to use those parallel line properties. Okay, so for the next two problems, we are given that LR, LW, and RW are mid-segments. Solve for X. Now, if you remember from above, one of the properties of a mid-segment is that it's half of the length of the third side. So if I look at this segment and this segment, this small segment is half of the big segment. So if this is 20, half of 20 is going to make this segment right there 10. Now I can use that idea to go in the other direction as well. If RL is 12, then OE is twice as big. So depending on the information you're given, it's going to depend whether you take half or you double. Since I'm given the small piece, I double that to get 24. And I'm given the small piece again here. LW is 8, which means that FE is going to be double that, which is 16. We want to find the perimeters of our two triangles. We can start with one of them. So if I start with the big triangle, triangle FOE, we have perimeter, we just add up the three sides, and we find that our perimeter is going to be equal to 60. So the perimeter of triangle FOE is 60. There are two different ways in which you can find the smaller perimeter. One, we have all the numbers, so we could, if we wanted to, say that the perimeter of the small triangle LRW is 8 plus 12 plus 10, which is 30. Or remember, because the larger side is always going to be double the smaller triangle, if I have my larger triangle's perimeter, I could just take half of that, and I don't have to do any additional adding, and I could go ahead and find that the smaller perimeter's triangle is going to be 30. Now our directions also wanted us to solve for X, and here was our X. Using that FO was 20, we had the big segment, so we cut that in half to find the smaller segment there. And we have that that's equal to 10, so we know that 2x plus 2 has to be equal to 10. We move our 2 over, we get 2x is equal to 8, we divide by 2, and we find that x is going to be equal to 4. All right, our last one is finding all of the missing angles, and this is going to require us to use those parallel line properties. So we know that this line is parallel to this one. We know that this mid-segment is parallel to this mid-segment. And this mid-segment is parallel to this one. Let's just start with one of our angles. We have 48 right here. If I use corresponding angles, I can find that that's going to be 48 as well. One of the tricks, and we're not going to go through all of our parallel line properties, which you can use here. What I want you to know is that these three triangles, the top one, the bottom left, and the bottom right, all end up being congruent triangles. So here, here, and here are the exact same three triangles. So if I see 48 here, and we did parallel lines to find 48 here, I know that this is going to be 48 as well. All bottom right or bottom left angles are going to be 48 degrees. So if I look up and find 65, 65 is going to be all the top angles. So that's 65, this is 65, and this is 65. And then we have a third angle. We're going to use our third angle theorem. Oops. And we know that that is that all three angles of my triangle have to add up to 180. So we do 180 minus 65 minus 48, and we end up with 67. So if this is 67, this is 67, and this is 67. So now I have my three outside triangles. All I need to do is find the measure of all of my angles on my mid-triangle, that triangle inside. And when we look at these angles, we're going to use linear pair relationships. I see right here, I've got a straight line, and I know that all three angles in a straight line have to add up to 180. I have 48 degrees here, and I have 65 here, so I do 180 minus 48 minus 65, and I end up with 67. Now you'll get to the pattern where you know that a triangle has three angles. I'm going to be using these three angles over and over again. So 48, 65, and 67. 67 was the one of those three angles that was missing. So if this is 67 and this is 65, the three angles I'm working with, this one is missing the 48. This is 67, 48. What am I missing? I'm missing the 65. So you can use that pattern. You can use linear pair, or you can use triangle sum once you get into the inside. But it is important, remember, to know that the top, the left, and the bottom right are three congruent angles, or a triangle, so all of our angles are in the same spots. The mid-triangle middle has those three angles just in a little different order. It's a rotated triangle. And that is it for this video.